No one makes a super scaled DIY 3D printable microcrawler chassis with leaf springs, front mounted motor, divorce transfer case, and an offset front differential housing just like the real thing. In today's video, we learn a painful lesson as to why that's the case. Hello everyone and welcome! The Scale RC shenanigans continue with this custom 3D printable RC crawler, trail truck, and maybe pavement princess chassis. We'll go with that. For those of you who have been keeping up to date with this channel over the recent months, you'll know that I've been playing around with tiny front steer axles and transfer cases, but bit by bit over the past few weeks, I finally put it all together into a functional RC chassis that has certainly captured some attention over on our social media pages. I figured I'd go ahead and put together a quick video going over this chassis and give you all an update on the insanity I've been subjecting myself to. Now there won't be a ton of building or CAD modeling in this video, as I basically did all of it off camera due to the amount of repetitive assembly and disassembly, as well as the fact that I've been mostly working on this sporadically in my free time, making it not so conducive to constantly be setting up the camera. In general, when I make videos, I really like to show, not tell, show the build process, not just talk about it, but I can assure you at some point in the future, as I start to iron out the bugs, I'll give you all an in-depth look at the printing and assembly process, as well as building a nice model kit to go on top. That said, if you're in the mood for some RC build content right now, and you'll excuse a tad bit of shameless self-promotion, over the past few weeks I've uploaded a couple of full build videos featuring a really nice 85 Pontiac Trans Am and 77 GMC General. Both turned out looking and driving great, and feature detailed interiors and engine bays. Just a week ago, I wasn't even sure if this chassis would work, or work well enough to be worth pursuing. But since there seems to be at least some potential here to build something cool, I'll definitely be giving you all a closer look at the final design and incorporate this chassis into a future project. But for now, here's a look at this chassis in its current state. If you've been paying even the slightest bit of attention to the RC crawler market in recent years, you'll know that smaller scale crawlers have become very popular. They're low priced, easy to travel with, and are lots of fun to drive even when indoors. There's no shortage of awesome vehicles to choose from, including some great rigs I've showcased before on this channel. With this in mind, you might wonder why I would bother creating my own 1/24 scale chassis design when so many affordable, capable, and durable options already exist. The short answer is scale realism. As you'll know if you've been following this channel for just about any length of time, I really enjoy doing plastic model to RC conversions. With some of these projects, I try to retain as many scale details and parts included in the kit as possible to make the finished vehicle look as close to the real thing as I can make it. For these types of projects to even be a possibility, I need components that are the correct size and fit right in place of the non-functional parts included in the plastic model kit. This isn't the case when choosing a popular crawler platform like the FCX24M for a model to RC conversion. These components here are too large, despite this being advertised as a 1/24 scale vehicle. 3D printing my own parts also enables the possibility to print these components with nearly endless variations. A few simple tweaks to the design of certain parts can change the overall wheelbase and width that the chassis has, allowing many different bodies to fit. Though maybe the most important reason of all is that it's fun to build something custom. Don't get me wrong, if I wanted to build a proper rock crawler, I'd save myself the time and effort and simply choose one of the great microcrawler platforms currently on the market, which undoubtedly will have better fitment and durability than anything I can 3D print here in the shop. I don't want to 3D print just for the sake of 3D printing when a couple $100 will buy something vastly superior. What I'm trying to build here isn't really a crawler, more like a plastic model kit of a 4x4 vehicle that just so happens to be drivable. Of course, it'd be nice if it could conquer some somewhat challenging terrain equivalent to what the real thing could handle, but this is secondary to building an authentic replica of the real vehicle. That's where these tiny custom 3D printed parts can really be put to use. Not trying to build a comp rig, just something super scale that will be fun to build and can cruise down the trails. Of course it helps that some components like the MA10 axles were designed already for use in rear-wheel drive live axle vehicles. With a few tweaks covered in a prior video, I was able to modify a rear axle design into a front axle with an offset differential and steering knuckles. I look forward to the challenge of making this chassis look as lifelike as possible while remaining reasonably durable and capable off-road. Success might not be guaranteed, but I'm certainly going to try my best. If anything, it makes me appreciate the work that goes into the design and manufacturing of the mass-produced vehicles we all have sitting in our collections. Whether you prefer the ready-to-runs, kits, or designing and building your own unique vehicles, there are countless ways to enjoy the hobby. Probably the best thing this chassis has going for it, and is really the main reason for its existence, is its size just about perfectly for a 1/24th or 1/25th scale Model to RC conversion. The axle housings, frame, transfer case, and motor are really close to being the same size as the non-functional components that will be included in the plastic model kit. This means that they're true to scale and could potentially be installed right in place of these parts, enhancing the lifelike appearance of the finished model. If anything, this 3D printed frame and axles that I've put together here is definitely on the smaller side compared to these full-size Dodge and GM truck frames I have from some kits. No worries though, as I specifically wanted this chassis here to represent about the smallest size wheelbase and width that is currently possible with these parts. As it sits now, the overall width is about 70mm, though with a slightly narrower frame and OEM-style pizza cutter wheels, this could be reduced. The wheelbase is about 88mm. Basically, I wanted a chassis small enough to work with vehicles like a Jeep CJ or Scout 2, but of course also work with larger, full-size pickups and SUVs. Even with this FDM 3D printed frame, it still has a nice scale look, with a motor and drivetrain layout you won't see on a ton of other 1/24 scale chassis. And that's really the number one requirement, as any compromise here, such as enlarging components for added strength or better performance, would beg the question of why not just go out and purchase a pre-existing platform, as again there's certainly no shortage of small-scale crawlers and trail trucks currently on the market. To a reasonable extent, deficiencies in performance, durability, or ease of maintenance can be excused if the finished model looks accurate. Of course, the fact that every part of this chassis is either 3D printed or is just basic and expensive hardware is pretty awesome, though there is one exception, which I'll talk about later. Definitely built, not bought, and for me that's a big part of the enjoyment of the hobby. Nothing like the satisfaction of creating something from scratch, well, at least as long as it works. These N20 motors do a great job of powering smaller scale models like this. Are they as good as some of the really impressive brushless options for smaller scale crawlers that are now available? Certainly not, but considering how cheap and easy to obtain these little motors are, they work pretty well, and this here is certainly no exception. No complaints with the powertrain here. I don't need a huge range of both speed and low-end torque, just something that's capable of slowly rolling over obstacles without requiring full throttle, and have a reasonable top speed would be nice, but it's not like I'm going to be racing this thing around or trying to catch some air. I've played around with a few different RPM N20 motors, one being a 2000 RPM, which has a top speed of about a walking pace, but too little torque at low speeds. I've also tested a 150 RPM motor, which has tons of torque and is great for some slow crawling, but it's too slow at full speed. Obviously, I'll choose an RPM somewhere between these two, certainly not disregarding brushless power and control as a possibility in the future, but for now I'll be sticking with these brushed N20s. As you might be able to tell, this truck doesn't run super smooth at low speeds. It has a bit of a stop-start motion, which I believe is primarily a result of some slop in the drivetrain. Can't imagine where that could be coming from. This is obviously a bit undesirable, especially on a vehicle which I really want to look lifelike at lower speeds. To be fair though, even crawlers from big name brands have a certain amount of slop in the drivetrain. Of course, the smoother the better, but probably a certain amount of slop I'll just have to accept. It was worse before, but it's sort of getting to be a minor nitpick at this point. I think I'm getting it to run about as smooth as it's going to get. Of course, the drivetrain, which includes 3D printed drive shafts and transfer case gears, doesn't really help with making this thing silky smooth. I should be able to showcase more of the assembly process in a future video, but honestly, I don't think it's terrible. I'm definitely a little tired at this point of all the constant assembly and reassembly required after pushing certain components beyond the limit and testing out different parts. But as far as the small scale models go that I've put together, there's nothing here that really presents too much of a challenge. Of course, that said, it's probably a much bigger pain than just about anything else on the market advertised as a 1/24 scale crawler. I guess it's just a matter of perspective, but overall I don't think it's too bad, all things considered. The DIY spring couplers connecting the inner and outer axles on the front end have proved to be pretty strong and work decently well. There's certainly more than a little slop, but at least for now, it's a dirt cheap and extremely simple solution. The transfer case, however, needed to be reworked, as finding a stiff enough rubber band to link the front and rear drive shafts turned out to be more difficult than I anticipated. Because of this, I ended up doing away with the rubber bands and designed 3 small gears, which can be 3D printed and installed instead. These tiny gears seem reasonably durable, but time will tell how well they actually work in the long run. I did experiment with a few different designs with different numbers of teeth on the gears, trying to strike a nice balance of smooth operation while also being relatively easy to 3D print. I'd really like for these files to get to a certain level of polish where I feel confident releasing them publicly, but I can tell you right now, you'll definitely need a small size nozzle to print parts like this. With a reasonable degree of accuracy, this is about as small as my printer can go with a 0.25 size nozzle. And finally, to conclude this segment about everything that's good about this chassis, it has leaf springs. Sure, leaf springs certainly have their disadvantages, and those coil springs sitting on top are certainly doing a lot of the heavy lifting, but come on, leaf springs are cool. Just a mono leaf on all four corners right now, but that could of course certainly be improved in the future and made to look more scale. Leaf springs are super simple and are what would be seen on many 4x4 vehicles, particularly trucks built before the 1990s. A 3-link or 4-link style suspension is something I might consider in the future, but again, I'm not looking to make anything too extreme or crawler-like here. At that point, I just get an actual crawler chassis. This here will really only be used for replicating bone stock or lightly modified 4x4 vehicles. After lots of testing, I was hoping that I could get by with the basic resin ring and pinion gears in the axles, but I've determined that going with the brass gears is the choice that makes the most sense. The resin gears are at risk of breaking or wearing out, while the brass gears are basically indestructible. Being that the ring and pinion gears are kind of a pain to replace, it just makes a lot of sense to make them the strongest part of the drivetrain. By the way, in all of the driving footage that you'll see in this video, there is essentially no front-wheel drive, as the resin ring and pinion gear in the front axle were pretty thoroughly stripped. Haven't gotten it swapped to brass just yet. I'm making this video while I'm taking a break from working on it. Regardless though, as you can clearly see, this chassis is going to be a real comp beast once I get those gears swapped. The FDM 3D printed transfer case gears might get the same treatment, however those seem to be holding up to reasonable abuse, so I might be able to get by with them. Now what's the big deal with brass, you might be asking, and why was I hesitant to install them in the first place? Well, unfortunately they're relatively expensive, at around 20 bucks a piece or close to 80 bucks for 2 sets, both for the front and rear. These are the same gears that are produced for our FFR SC1 chassis kits. That chassis uses basically the same MA10 axle design that I have here, and being that these parts are not mass produced, they can get a little pricey. 80 bucks for basically indestructible gears that will easily last the life of the vehicle isn't terrible, and let's be real here, if you're afraid to spend money, I don't recommend getting into the RC hobby. It's just when every single other part of this chassis ranges from a few pennies for the 3D printed parts to a few bucks for the electronics, it starts to feel like spending 15 grand for a high-performance LS V8 that you're dropping into your $500 project car. It just feels a little strange, I guess. It's probably a good time to point out that comparatively giant all-in-one receiver and ESC, as well as the 2S LiPo battery that you'll see mounted on this chassis, is not what I plan on using for any projects. As you may be aware, there are much smaller components on the market that can be easily hidden away on a super scale model car build. Obviously, I'll be using something more along the lines of these components instead. What I'm using in this video is just for testing. It's probably also worth pointing out that these tires are absolutely terrible for any sort of driving. These are the solid, hard, rubber-like tires that were included in a plastic model kit with absolutely no give whatsoever. They look nice, but for anything beyond very mild trail driving, I'm certainly going to need to source some actual RC crawler tires to provide at least a little bit of grip. I'm not sure how hard finding some tires this small would be, but I have a feeling with the massive variety of micro crawlers on the market, I could probably find something that's the size I need. Maybe something advertised as 1/32nd or 1/35th scale, like the tires available for Orlando crawlers. But hey, at least there's no risk of these tires going flat. Always have to look at the glass half full. It would be nice to see if I could get a little more steering angle out of the front. It's not like I need a super tight turning radius, but it's not great at the moment. I think a few refinements to the steering knuckles, such as making sure the tie rod isn't coming into contact with the diff cover, will help. As you may be able to tell, I've also put some notches in the front leaf springs to allow the wheels to steer a bit further. It helps, but it's certainly not a perfect solution, so it's something I'll continue to experiment with. One of the things I've spent a lot of time on is trying to reduce or eliminate any vibration in the driveline. This can be a bit easier said than done, especially with a lot of 3D printed parts like on this chassis. However, various refinements, such as redesigning the drive shafts, has helped. As I mentioned before, the chassis has a bit of a stop-start motion when driving at slower speeds, which is not ideal, especially for something that I want to look as lifelike as possible while driving. Admittedly, most of the design work that you see here was done pretty quickly and without a ton of prototyping and thought put into the overall design, As a result, I think to really get the most out of this concept of a super scale 4x4 chassis for Model to RC conversions, I'd have to do a pretty thorough redesign on a lot of these components. Basically take what I learned here and use it as a reference to start from a clean slate and make various improvements throughout the entirety of the driveline, axles, and frame. Not out of the question for a future project, but for now I'm going to work with what I've got here and try to do the best I can with it. Hopefully at some point I'll have something refined enough to where I feel comfortable posting the STL files for others on our Patreon, but for right now there's certainly some things I'll need to improve before it gets to that stage. While there's still a few more things on this chassis that need to be ironed out, I think it's just about time to get this thing painted, put a body on top, and see how well this truck holds up out in the field. I'm very fortunate to live near plenty of terrain that will be absolutely perfect for a truck like this. Miles of very mild trails, and acres of smooth rocky ground just like this. If I didn't have as much environment like this to run a truck this small and detailed on, I would probably be a little less excited about a project such as this. I think having plenty of local options of where to drive your RC vehicles, whether super tiny, super scale rigs like this, or on the other end of the spectrum, large scale bashers capable of tearing up the sod and breaking some shins, it really makes a difference on how enjoyable the hobby is in my opinion. I've got plenty of 1/24 scale and larger rigs that are great for tackling some more difficult terrain, but with this chassis, at least in the beginning, it'll be much more about traveling some distance and seeing how reliable it is. Think less We Rock and more Camel Trophy if that makes sense. Of course, any project incorporating this chassis is going to be as much about the model build as it is about actually driving it. If I want to build anything more than a bone stock or lightly modified 4x4, I'll choose one of the many great crawler platforms currently available on the market. This platform here is for when I want to build a plastic model kit that just so happens to be fully drivable. Since posting some pictures on our social media, I've gotten a ton of interest from people who would like to buy a chassis like this. While certainly flattering and I do have to pay the bills, the harsh truth is that this platform is way too sketchy, fragile, and rough around the edges to be something I'd want to sell. Never say never, I suppose, but I feel like a lot of these components like the gears would have to be made out of metal, which would drastically increase the cost to the point where it would now be priced above the huge selection of awesome micro crawlers and trail trucks currently available on the market. It looks cool, seems great on paper, but I think in reality this would only appeal to a very narrow sliver of the market. Right now I wouldn't even consider it refined enough to post the STL files onto our Patreon for others to 3D print. But eventually if I'm able to make the necessary improvements, I think that's the best way to go. For the most part, I think a hobbyist seriously interested in doing a build in this scale with this level of detail and only utilizing basic hardware and springs like what I've done here would have and be able to proficiently use a 3D printer, in the same way somebody seriously interested in restoring a rusted steel auto body would probably have access to and be proficient with using welding equipment. All that said though, if you want to buy a chassis kit right now, at least kinda similar to what I have here, but not actually have to design it from scratch or 3D print anything, some of the kits offered by Orlando are probably about as close as you'll get to something like this chassis, at least as far as something that can be adapted to use with 1/24th and 1/25th scale plastic models and is reasonably priced. As I've talked about before, I know a lot of these chassis and vehicles are advertised as being around 1/32nd or 1/35th scale, but if you look at the actual dimensions, some of these components seem like they would work pretty well for a 1/24th or 1/25th scale model. Of course, you could always just build the kit with the included bodies, as they do have a pretty cool selection of different vehicles to choose from. But at this point, the chassis is coming along about as good as I could hope, and right now I'm going to work towards the goal of getting this thing looking like a truck and get it out onto the trails to see how long it survives. I hope you'll stick around for that update, but that's going to be all for today's video. As always, thank you all very much for watching, and I'll see you next time.